All right, so to give a better idea of what we're looking at right now. So we have back probed into the output to the oil pressure sensor. In this case, I have a potentiometer. We're just using the middle leg, so I have variable resistance to ground. It's a good ground source. And we've trimmed the pot to where, as you can see, second gauge from the right is oil pressure. Let's see if we can zoom in on that. And you can see I get it dialed into 0, and we get our check gauges. Basically, this is how the sensor setup works in the car, is that it takes a resistance from the oil pressure sensor, and then that controls the gauge. Now, normally there is no input to the ECU, there is no middleman, it's just the sensor itself. Now, what I'm running is a standalone, so the standalone itself needs the oil pressure. So that's an input to the ECU. So now I'm using an output from the ECU to control that. So, one moment. So, we now have same back probe. We have my oil pressure with 7 ohms of resistance from the potentiometer. And when we have it running, you can see that it goes through a table, and essentially it outputs a pulse width modulated signal to ground. Now it runs through that initial resistor because that resistor indicates 0. So that 7.5 ohms is, come on focus, the 0 PSI, and then essentially I outputted 0, and I found where each one of the quarter marks is, and then I had it create a pressure table, and now you can see that I get the output of the oil pressure sensor. Now, annoyingly, it's not doing what it was doing before, where essentially it was saying check gauges. So, you can see as I rev up and down, more or less oil pressure in the engine outputs, and originally I had the check gauges warning that came along directly with the oil pressure sensor. Now, I do know, and I'm going to turn this off real quick, I do know that the pulse width modulation can be a little hard on these kind of coils. I have the magic of having a second instrument cluster. You can sort of come over here, and we can see this is the oil pressure, the actual gauge itself, opposing magnetic fields controlling it. So it would prefer a smooth voltage, or a smooth resistance voltage drop that controls the actual gauge itself. The pulse width modulation obviously is a little bit harsh. I'll give you a view of the PCB layout. So this is the control side. You can't see a lot of the traces, but you can see minimal ICs. Most of this is not controlled by solid state. As we make our way back over here, you can see the pins, the 3 that control the oil pressure gauge, and if you follow the traces, you can see that most of these, or at least this one, is the sense, comes all the way back to the electrical connection, and then one of these goes to the ground plane, marked by negative, and then the positive, there's a, as it goes into here, it's not the light bulb itself, but it passes through a resistor, which then also feeds into the check gauges. This isn't part of the diagram that's been provided, but it uses one of these chips. I'm sure we could trace the actual trace itself to see where it goes, but that's what goes to the check gauges illumination. That says that basically one of those gauges that is reading below spec is something that wants to get the driver's attention. So my idea is essentially that because the input is pulse width modulating instead of being a steady resistance, I wanted to smooth the signal out either with a capacitor, the idea being that a capacitor would discharge in between the peaks, and then therefore, again, since it's variable resistance, we're talking about the voltage drop. And then alternatively is an inductor, so that the voltage drop every time it dips down, it doesn't necessarily, cause that jolt of down, up, down, up, down, up. It would smooth out that operation. It would require me to calibrate the output, but that's just a simple table, so that's fine. But that's kind of what I'm looking for, is how can I smooth the signal that runs this gauge, which is meant to create a voltage drop across a resistor to move the needle, and instead I'm pulse width modulating ground. How do I smooth that grounding out so that I can either open or close the gate, so to speak, ground more or less based on the duty cycle, to operate the gauge between the various points, so that instead of, again, just constantly switching that on and off, I have a much more gradual voltage drop for it to measure in order to actually operate the gauge.